the blue color there, this is indicating that the thermocline started to coming back, and this is actually because of the Kelvin wave. So Kelvin wave play a role in this, but as I showed earlier, that El Nino changing into the normal to La Nina and so on, all this actually controlled by a so-called delay in oscillator. I don't want to go into this because a little bit too detailed to explain. So for the last 50 or 60 years, as you can see that we have many El Ninos with different strength. There are actually very extreme El Nino, moderate, but we do have La Nina as well. So this is you can find this from in the internet, some kind of general patterns of impact of El Nino worldwide. In our region, indicated from June into January, somewhat drier, but this is actually not true. As I'll tell you later on, it's actually dependent on what season. Similarly with La Nina here. So now I started to work with these El Nino things when I did my PhD, which I had opportunity to develop a model to forecast the El Nino using this so-called artificial neural network. But these days, AI is a very famous scientific field. But when I started to use this big data and AI in more than 20 years ago, people find it rather strange. But this is actually the entry point that I made when I started to work on the El Nino. In that model I developed actually was used by NOAA to forecast El Nino as indicated by UBC neural net there. So it's been used for more than a decade to forecast El Nino as one of the model actually. Focus El Nino. But my supervisor has retired, and since his retirement, that model was some sort of disabled and replaced with some other models. So when I came back to Malaysia, I devoted my time to understand how El Nino behave, how the impact over maritime continent, over Malaysia actually, when El Nino occurs. So this some of publication that I would like to share some of these if I have the time. So one of our particular paper that we have, we showed here that fluctuation on rainfall in Malaysia actually somewhat related to the El Nino. Changes over the Pacific as well as the maritime continent itself, basically. So I don't want to go into detail, but I want to spend time a little bit on here. So I also had an opportunity to work with Juning on looking more detail of this, where we use the so-called the EOF or EOF, empirical extended empirical to the function, where when we apply this analysis to a gridded data set over the Pacific Ocean as well as rainfall over maritime continent, we can see two patterns basically. So we apply this independently to the SST in the Indo-Pacific region as well as the rainfall gridded rainfall data over the maritime continent. We find that the temporal mode that modulate this major mode, which is the El Nino, basically they are coupled together. The correlation is very high, almost 0.9. That shows that these two patterns basically correlated very well, and not surprising that the first mode in the Pacific Ocean, in the ocean, reflect the El Nino evolution. But what's surprisingly is that previously we thought that when it's drying, it will be drying throughout the El Nino period, but it's not. As you can see here, this is the evolution from GGA, the beginning of El Nino occurrence, to the end of it, the following year. So you can see that the blue here changing over time. Okay, as you can see that the dry period over Indonesia, Malaysia during GGA, it will extend into September, October, November, and December, February, December, January, February, and so on. It's like there's some progression of this, some kind of pattern progression. So the immediate conclusion is that the dryness does not fix in a particular area, but changing over time, basically. So I had a chance to visit this problem with another paper for Malaysia and also another paper opportunity to work with Malaysia student from Indonesia. So this is another when we compose it, meaning we average many El Ninos over different seasons. As you can see, this is a particular indices. We call this CDD or constituted dry days. As you can see that during GJA until SON, dry period over Indonesia, throughout Indonesia basically, and this is why you have forest fires over Sumatra and Kalimantan during June, July, August, September, October. But when come to December, January, you can see the green patches there, and that green patches is expanding. When you starting from December until March, April, May. It's to some point that during DGF, the northern part of Borneo, which is Sabah, still very dry, but over Kalimantan and Sarawak is basically, you have more rainfall. And this is what happened in 2016. In February 2016, I had opportunity to travel in the interior part of Sabah. It was very dry because of the El Nino 2016. But over Sarawak, over Kalimantan, actually flooding. So this is actually pattern that consistent with I showed you earlier. Okay, so there is a reason for this. The reason for this basically associated with the AC interaction over this region. As you can see, the evolution of SST during GJA, a little bit of cooler SST over area of Irian Jaya and so on, but that SST be expanding, and then retracting and retracting, So because of that, you will have this is the third row there, basically as a so-called P velocity indicating of the indication of the subsidence. As you can see that during GJA, almost the entire region of Indonesia, Malaysia experiences subsidence, but that is changing as you go through over the period. And if you look at the integrated moisture flux, you can see that kind of changes. And basically, you have this so-called divergence during GJA. The whole region during SON, you're starting to see this so-called intercyclonic, both in the southern and northern atmosphere, and the convergence in the convergence between these two intercyclonic. Basically, you can see this slightly green over there, which is increase of rainfall, and that thing tend to expand. Tend to expand, and following the following month. So why this is so? This is actually associated with the theoretical. Whenever you have heating in the protropical here, it generates this anticyclonic, and this anticyclonic basically here is only shown only one anticyclonic here, but you have another one here. But this is the one here that actually becomes stronger because of the SST over this region, the dipole SST that I showed earlier, as well as because of the seasonal modulation. During the GF, this is the one here. So basically, what you see, the modulation of rainfall, the seasonal modulation of rainfall, basically, modulated by this strengthening and awakening of this, system. So that is why you have this kind of you don't see drying all period, but you see this drying pattern, but followed by rainfall pattern during El Nino. So if you say that it's drying throughout the El Nino period, that is actually not correct. But there is also some differences between El Nino and IOD, co-occurrence. What we saw earlier basically is more like the co-occurrence of IOD and El Nino, So that is what the typical pattern that we see. But there is also a time when El Nino occur by itself and IOD occur by itself. There is some similarity, but there is also some differences, and I don't think I can talk in details. This is another. This is a composite, but this is another. A plot that we can obtain by doing a partial correlation. Between the 3-point index, IOD, and also the rainfall indices, basically. So in terms of SSC anomaly, there is some differences, some similarity, but some differences between IOD, co-current between IOD and El Nino, which is combined together as compared to El Nino by itself, IOD by itself, basically. So, okay, I have about 5 minutes or so. So this is a climate. I want to talk about this. So climate basically, because of greenhouse gases, temperature has been rising. But on top of that, we do have individual things, but every peak of this is showing El Nino. So in the future, temperature will keep rising, but we don't know about El Nino. But for sure, El Nino will be there. So it's possible that in the future, the effect that we will have will be a combination between climate change and climate variability, which is the El Nino. So this is one of the questions that we try to answer. And we do have this so-called Codex, which is a worldwide program where we participate in the projection of climate. So we do this by downscaling a number of models, and Dr. Chung Jinxiang basically part of this. And I'm leading this project in Southeast Asia, basically, and we have done quite a lot. In fact, last week we had a workshop. And this is the model that we actually done downscaling. This is, I would say, a lot model compared with 1 or 2 models that previously people have applied before. So, but one of the important things that I would like to show here, this is actually the projection of CDD, dryness over Malaysia and also over the maritime continent, Indonesia, when global temperature reached 2 degrees and 4 degrees. As you can see that this is average over many years, about 30 years or so. And when you do averaging like this and averaging many models, you tend to kill the El Nino inside the model. So what you have here basically is average, and you expect this to occur annually in the future. So it means that in the future, you don't have to wait El Nino to occur, but this is a drying pattern that you will see. And the magnitude of dryness here perhaps correspond to what you experience in El Nino in the current year. So, so this is a very significant result because it means in the future, you don't have to wait for El Nino to occur because of climate change. You will have this kind of dryness, to occur in the future, even without El Nino. But of course, El Nino will still be there, and in conjunction with El Nino, perhaps the dryness will be much worse. Because El Nino pattern like this will be still there in the future, of course. As I showed you earlier. But to make matter not very nice for us, there has also been a study shows that in the future, extreme El Nino, like 2016, 2017, 97, 98 El Nino, 82, 83, it tend to be more in the future, twice more in the future. This is a study by CSIRO scientist Wenju Chai, who showed that they have looked at different models, and they look at what happened to El Nino in that model in the future, and they showed that in the period of warmer period, almost the end of the century, the extreme El Nino tend to occur more in the future compared to in the current climate, basically. So this is bad news. One, even without El Nino, we tend to be going into drier in the maritime continent, including Malaysia, more in Indonesia. If we have El Nino at the same time, that the dryness could enhance on that particular year whenever El Nino is there. But we also hear this result that El Nino tend to occur more. Extreme El Nino tend to occur more in the future. So so that's a very important result. Okay, so I'm almost the end of it, but I'd like to show you the current condition in the Pacific Ocean. Basically, we have moderate La Nina. This is actually the latest SST. Latest SST. This is actually the so-called INSO update by the INSEP NOAA in the US. As you can see that the pattern here resemble to El Nino La Nina pattern, cooler temperature in the Pacific Ocean and warmer here. And you tend to also perhaps notice that last month or this month, in the Philippines you have 3 or 4 typhoon. That is because you have warmer temperature over here that tend to increase the formation of typhoon. So as you can see that 100% La Nina here, the probability, and that will of course reduce. And by next year there is a possibility of going to be Lino, who knows. And in the Pacific Ocean we have this tau array, and we have something like this, and we can measure the real time. As you can, this is a subsurface temperature. As you can see that cooler surface temperature associated with El Nino. So it means here the thermocline uplifted, but because of that, because of a strong westerly wind, easterly wind going to the west, that is basically pushing the thermocline down, create the Kelvin wave, and that Kelvin wave will propagate and terminate this La Nina by early next year, basically. But something that I want to point to your attention here is that based on our paper 2017, this is actually this is a moderate La Nina. This is a pattern of average moderate La Nina. As you can see that the pattern on the left side here is correspond to more or less the same what we have in the current pattern of SST. Where slightly cooler or less in the Indian Ocean, in the South China Sea, warmer over here, warmer over here. It's a very strong resemblance. But in this paper, through our composite, we looking at for moderate La Nina, you tend to have more extreme rainfall. So this may point us to something that we need to be aware in the next couple of months, December, January maybe especially, that rainfall, extreme rainfall may increase because of this moderate La Nina. Interesting, as you can see, strong La Nina, you have dry, but moderate La Nina tend to have higher, So all this because of the teleconnection pattern. So I think that's my last slide, Dr. Chong.
Okay, bro.
So I just leave it there, in case there is any question.
Okay, thank you, Professor Fred. For now, ladies and gentlemen, this is our Q&A session. If you have any question, you may drop it at the chat panel, and Professor Fred will try to attend to you.
I cannot see the chat. I have to end this.
Yeah, okay. I will help you on this too, Prof.
Yeah, okay.
Yeah, please, if you have any question, please feel free to ask. Maybe we have a 5-minute Q&A.
No question?
No question.
Maybe I went too fast.
Yeah.
Just one question, Prof.
Yeah, sure.
With all those models that have been developed so far, how accurate now in terms of predicting El Nino and La Nina by climatologists?
I think the models are getting better and better. This El Nino research has been started since early 80s. That's more than 40 years or so. So the model becoming more accurate. El Nino basically can be predicted rather well in advance, at least 6 months in advance, very accurately.
All right, thank you.
Yeah, Prof, there's a question from Amiro. He asks, is there a possibility for extreme flooding like 2014 to happen again this year?
I don't know. I don't want to say, but I stand by the data that we have here. That whenever you have moderate La Nina, you tend to have extreme rainfall. This is not model. If I can share here, this is not model. This is actually from observation. From observation that we have, we average SST here from many moderate La Nina, not only single one, many moderate La Nina, and this SST pattern actually strongly resemble to what we have currently. Okay, what we have currently. So when you look at rainfall data at many stations, it seems like we do have a lot of rainfall. In fact, in Perak now, I think it's flooding, isn't it?
Yeah.
Yeah, in Perak it's flooding. So whether we have flood in 2016 similar to 2018, I'm not really sure. I don't dare to speculate here.
Okay, thank you, Prof. If anyone want to ask directly Professor Fredolin, you can unmute your mic. You can just ask straight away. Don't be shy. No more question?
I guess no more question.
I guess if
Chong?
no more question, then we reach
Yeah,
the end of this
stop
section.
stop sharing it.
Yeah, Prof, maybe you can stop sharing this. I think if there are no more questions from the participants, perhaps we'll end this session. And I think we'll continue with the next agenda. Okay. So I guess that's it. Thank you, everyone. Thank you, Professor Fred, for giving a very informative presentation. Yeah, I think this session ends here. You may leave the the WebEx. Thank you.